Yes, welcome back. Moving on to Naynar's managed signer. Let's see what they are doing. Writecast with managed signers. Make sure you have Node.js Neon installed. Setup, environment configuration. Naynar API key, Farcaster developer mnemonic. Make sure the value is within single quotes. Developer account is same as any Farcaster account. Okay, you can use your personal account as a Farcaster developer account, or your company branded developer account like this. Yes, so I was right about this piece. So this Farcaster account for each company, in a way, this is what Naynar developer account is, the same as that. Then this signer gets instantiated through this, which you can use for everything. Start the app, start the sample Farcaster app. Your app should now be running. Troubleshooting. Variables are correctly set. Okay. Now let's go through it. Naynar API client, just pass in the API key. One thing that I am curious about, Farcaster developer mnemonic will be my signer. Alright, should be fine. Naynar API key, so validate Naynar as true is calling. Fine, this is okay. Naynar client, just an API key and you instantiate a client, that's fine. Loading get fit get signed key. So what we need is a Naynar client. We need the VM local EIP 712 signer that we have just seen the example of. Signer VM 712 local EIP signer. And the sign key request from this. Mnemonic to account from VM accounts get fid. Okay, get FID. So what are the functions that are here? One is get signed key, one is generate signature. So get signed key, what does it require? Get signed key, it requires you to create a signer. Fine, this Naynar developer account, same as your Farcaster account, you are generating a signer here. Create signer and then generate signature by passing create signer dot public key. So into generate signature, it is passing signer's public key. If I track Naynar managed signer flow, let's say I use my personal account. Arunank is the developer account. So it has my mnemonic, it has my public key, it has my private key. Using, actually you don't need to use these, like mnemonic to account, I am using VM mnemonic to account to create this signer. VM local EIP 712 signer. This is the first step. Once the signer is created, what is it trying to do is Yeah, create signer. I just generated the. One second. Nenar client dot create signer. I'll have to check as to how they are doing it from the API key. Create signer dot public. It may not be. Is it the same signer? Nenar client. Nenar Node.js SDK. Is it available in the repos? Node.js SDK. And diving deeper and deeper. In our API client, constructor API key. This is not needed. What we need is create signer. Clients v2 dot create signer. I have to go through a lot more code. v2 client. Create signer, returns the signer status. Create a new signer. Create signer. Okay, this is the documentation. Okay, get signed key also requires a get FID. Let me take a step back. What does FID do? Mnemonic to account. Get FID. developer mnemonic. Fine. Let's start with get FID. Get FID. So this is looking at Farcaster developer mnemonic, right? This means this is looking, if I am the developer, this is looking at a Renan's mnemonic. Basically my Farcaster account. Based on that, it generates the account. It generated my account for Farcaster. Look up user details using the custody address. So at inner client, you will look up user by custody address. Okay, so this account's address, it looks up and then it gets the FID, I think. Farcaster developer.fid. Interesting. I should console log this piece and see what all information is being returned. And look up user by custody address. User by custody address. This is the API to be calling. Custody address. User FID, custody address, username, display name, profile, via follower account, verifications. Okay, so all the information of a particular user, right? So it gets all my FC information. Farcaster developer.fid. When get sign key, what is happening? It creates a signer. So Nena client.create signer. If I call create signer, it returns me a signer UUID, a public key and a status. Alright, let's see this now. For developer account, this is not directly converting to the signer in this flow. I think this piece was incorrect. This remains as is. But what happens is that we give Nena the API key, and using this API key, Nena must be having some sort of a database where it is managing a UUID, private key, public key, and status. U1, P1, PB1 generated. So when I am calling Nena.create signer, yeah, this would also be having the API key. And this is what would be linked to my FC account and my Nena account when I am going through the dev portal. So Nena.create signer, what this is returning is U1, the public key and generated, U1, pb1 generated against API key. Fine. Now once I have this public key, I pass it into generate signature. This generate signature takes a public key. Yeah, sorry about that. There's a call that I got, had to pick it up. Anyways, what we are getting at is I just created a signer. Alright, so this is my state right now. Now this, well, let me move to where there is more space. Nainar dot create signer takes API key and returns a UUID, a public key, and a status as generated. Now this create signer is passed into the generate signer signature example, which takes in this public key. Plus, let's see what are the things it takes. It is calling Farcaster developer mnemonic, process.ini Farcaster developer mnemonic, and my FID. So for my account, mnemonic is generating my private public key, and using this it is also fetching my FID, like my all FC details. So FID, right? So there are two pieces of information coming in. One is there is some public key from the signer generated by Nainar that is coming in, and one is my developer account info or my private FC info that is coming in. Get FID. Now account Farcaster developer mnemonic. This is the account. Okay, basically this becomes the account. App account key. VM local EIP 712 signer account as any. Nice. So as we had discussed earlier, it is doing the same thing here. This is calling VM local EIP 712 signer. So my personal account, it's what is getting converted into app account key to app account key. That's fine. Generates an expiration date for signature 24 hours. Cool. Now uint address x2 bytes, public key as 0x string. 1 second, public key as 0x string. Okay, so now this is converting the public key that came in to 0x public 1 x. There are two keys accounts parallelly going on. Signature app account key dot sign key request. Nice. This is what I was clear on. App account key dot sign key request. Dot sign key request and request FID. Request FID is FID. No, it is my, so that is this FID. Key is the uint address. Uint address is what Naynar gave to me through the API key. Key is uint address, which is this. This is what is the 0x public 1 hex. This appeared from Naynar's API key. And the third one is the deadline. Which we gave as 24 hours. So one thing we clarified from here is, yes, this FID is the GFID, that Cloudsphere or the app's FID. This key which the app is generating for the user. If the signature is error, return this, else return the hex of it. Now once signature is generated, you take out deadline and signature. You get the FID here as well. And then what you do, you call Naynar client.register signed key. So you pass in the UUID, you pass in the FID, deadline and signature. What does this entail? This is, I think, the last part. Let's look into it. Alright, so after this piece happens, like deadline signature. So what would this signature done by app account key with this FID? Get the FID here for this particular key that was generated by the nailer. We'll call nailer and say, hey, register signed key. And in this, what is passed is that the identifier is the UUID. FID here. Deadline and the signature. Now the interesting thing is, okay, so because nailer has the FID, it can actually extract out my public key to validate the signature. It has the signature, it has the FID, because it has the UUID, so it will also have the signer that it had created, the public key. It has all the information to reconstruct the packet as well as signature, as well as validate that signature. Return signed key. So let's check out what this does. Register signed key. Hey bro, what are you talking about and why did you give example values? Well, let me see sample response. UUID of the signer, public key, status, sign approver URL, FID. Alright, so basically it registers that particular signed key. First instance it was generated. Now that I call it, it will register against my API key. Okay, this particular public key has been signed by this app and it is put in their table. So I got a signed key. This particular public key becomes a signed key for the app. Get signed key, get FID, here this is done. Now let's get into the app. And the page piece, this is a QR code Farcaster user. Now the user interacts here with the front-end app. User set user local storage dot get item. Cast display toast fetch user. How does this work? Let us go through it one by one. You land on my app. You see a QR code. This use effect is done. I'm trying to get from local storage keys. Is there something called Farcaster user? If there is, I just parse the stored data and set Farcaster user as that. If there is not, I don't do anything. If Farcaster user and status is pending approval, then I start polling every few seconds and I keep checking /API/signer UUID Farcaster user dot signer UUID. Okay, so this is after I've created a key for the user. Stop polling, handle visibility change. Get to this. What is going on here? Handlecast display toast fetch user. Farcaster user dot FID and then set this. Status is approved, then fetch user. If not Farcaster user dot status, and then this is what is to be rendered. Status is approved. Handle sign in, create and store signer. All right. Oh, we'll have to see as to how this renders and one after the other. Farcaster user has these things. This is the signed key. This is the manage signed key coming in from Nanar. This is what we saw, right? There's a signer UUID, public key status, signer approver URL, and FID. Text is casting show toast user set user. Check out what the API is all about. Cast signer and user. Signer API. Signed key is just get signed key. Signer UUID. Inner client would look up signer and then return the signer. The question is, how is getting linked to a user different from the developer itself? I think I should quickly spin this up and see. I'll quickly test it out in the screen. So I'm getting a sign in with Farcaster. Sign in with Farcaster button because there is nothing right now. If not Farcaster user, yep, then just create a button which says, if loading it says loading, otherwise sign in with Farcaster. This is what is being rendered in the first screen. Now when I click on this, it will call handle sign in. Handle sign in will be create and store signer. Create and store signer. It calls axios.post API/signer. API/post signer. It will get a signed key and return that. Now the signed key that it will get for my particular mnemonic. It says loading, and it generated a QR code on top of it. So get signed key. What does get signed key do? We have seen it. I'm just talking about the specific response. It calls get signed key created against my API key a public key, got it signed, then register signed key, registered it there, finally returned the signed key. JSON.signed key. Alright, so it returned this packet. What happens after the post request is processed? If response.status is equal to 200, local storage.set item. Fine. Local storage keys dot Farcaster user. So I saved all the details that came in, like these 5 things, into the local storage. And I stringified this response. Then I called set Farcaster user with response.data, so set of the user. Now updated the state, set Farcaster user. The moment Farcaster user is set, which of these use effects is going to be run? Let's check that out. Start polling, stop polling, handle visibility change, Farcaster user. Okay, so this use effect is run. Now I have a Farcaster user and the status is pending approval. Pending approval, this starts polling. What does this poll for? Okay, it is hitting my backend API with the signer UUID. And then inner client is looking at the signer and checking its status, whether it has been approved or not. Right. If status is approved, do something else. If not approved, if the user status is approved, set item JSON or stringify user, set Farcaster user. Okay, again update the state. It will stop all this polling, etc. But in case if it is not approved, if this is pending approval, then it's just start polling. Polling is going on, it has not yet been approved. Now let's see what will be the component or piece rendered on the front end. So Farcaster user status, okay, so this will get removed because now we have Farcaster user. The status is pending approval, and Farcaster user has a sign-in approval, yes, and then render a QR code with this approval URL. All right. Okay. So this QR code. Now this QR code will be scanned and given approval by the user. Once this is scanned and given approval by the user, status changes to approved. Status, one second. Yes, scanned and approved. Then this polling function is calling this, which in turn is calling the Nenar API for the signer. In that is checking if the status is approved, then it will update the user to approved. Set Farcaster user, cause this entire thing to re-render. Finally, it will enter this approved thing, clean it up, stop this, handle visibility change, and if this is approved, then we will render an image for users profile picture if it is there, display name, hello user. Okay, so what I was seeing was users details, right? Cast text area, this and that, button is casting, and then finally do it. So this app is in a way signing and doing it on the behalf of the user, right? Got it. What fundamentally is happening is Nenar, let's say I have Arunank, I have a dev account at Nenar. I also have this, my Farcaster account. For Nenar, both are the same. They are linked. So now Nenar against my Farcaster account or FID has a table wherein there is a bunch of UUID and it contains a private public key, their status. When I ask it to create a signer, it generates here U1, P1, PV1, status generated, and it returns that to me. Now, using my Farcaster account and this particular key that Nenar has, what I do is I showcase a URL or this QR code to the user which contains this information. Hey user, on this app I have created a public private key pair against your name, and what I want you to do is scan and approve. The moment they scan and approve, it would update the status here from generated to approved. So now this particular key pair or signer that Nenar is managing is assigned to the user one. Let's say this is user one of app. So whenever now user uses this app, it tells Nenar, hey, this user casted this using that public private key pair, publish cast, and other Farcaster interaction happens. So there are three entities that are interacting. One is the developer account, developer FC account, which has its public private key. One is your user FC account, which has their own public private key. This is kept in their Warpcast app and phone. And the third piece is the Nenar's table for managed signers. It is this table which is linking. It generates another set of public and private key, which is actually generated against the developer's account through API key, but it is in a way assigned against this particular user which approves. And eventually this is what is used to interact with Farcaster protocol, such as publish cast. I think that is why they also have a developer managed thing where signer by public key, register signed key, message of state of developer managed signer. This is Nenar. Nenar does that for you. Now this table, I think you also can do it on your, like instead of Nenar's table, you can replace it with your own stuff. And you can register your particular generated public private key pair with Nenar. Finally, I've managed to mostly resolve and untangle all the different pieces that are flowing together for managed signer as well as Farcaster core repo. Then this then shows that all I need to do is like move the API components that are happening here inside this app and API. I can move it to my Nest.js backend, wherein that is taking care of all these pieces. I can have a front end that just shows the QR code, and I can set up an auth between my front end and backend. In addition to, actually, I should set up the auth with respect to Farcaster auth itself. Right. So this piece should be sorted like. To my Nest.js backend, this API call, instead of going to the Next.js backend, it should go to my Nest.js backend with the signed UID. It will do the processing, return the user and the different status. Once QR code based approval happens, that is again front end component. That's just the app. All right, it should work out. What was my ref for the last few minutes? It was this. What I'm trying to build out right now is this. The managed signer app is a Next.js app. So within Next.js, there is the front end, which is your page, which is rendering the QR code and doing everything. And because this is a full stack, it has app/API, which is taking care of the signer, etc. So now what I want to do is move this piece into a separate dedicated backend itself. That is what I'm working on. So instead of this page interacting with this API directly, this page interacts with Nest.js. And now the next piece of challenge is to ensure that this front end and this back end are authenticated through Farcaster auth. So the second piece that I'll be modifying from Next.js to Nest.js, a dedicated backend, is going to be the Farcaster auth kit. That will be our next video. But I think this is mostly completed. The Hub-Monorepo, I've done a detailed walkthrough through the entire core package. If you want, you can look into Hub-Node.js. I think it's very similar to the core package. There are pieces that have been picked up from it, and I did not see a lot of difference. I may be wrong. Let me know if there is something that I am missing out on. For the web also, it's pretty like straightforward. Yeah, I think this core package is the most important. Inside the core package, protobufs, and even in that, this message piece, this is the heart and soul of the entire thing. Bunch of gossip, hub event, hub state, etc. for different hubs to interact with each other. Request response provides you a way to interact with the hubs itself. Then crypto contains the different signing mechanisms and the utils code for that. Finally, we have the signers that we discussed about. So signers are also very simple. You just have a couple of interface, and then they are implemented through different ethers and VM library. Finally, we have the verifications and the validations piece here. Now what I did for just a sign key request, similar things depending on the message type, such as reaction, link unlink, cast, etc. All those have different message bodies, their structures, and then they are typed using EIP 712 assigned constraints and protocol. Alright, so this concludes our walkthrough over the Hub-Monorepo. In the next series, I'll do a quick walkthrough over the Farcaster auth kit and moving it into a backend Nest.js sort of a structure. We'll figure out, walk through the code and see how we can modify this to fit our purposes. I think it would be part of auth monorepo. Auth monorepo. Yes, so this has packages, auth client, auth kit. Let's quickly check it out. Auth kit. They have examples, etc. Alright, it will be a fun series again. See you soon.